Okay, kids, here we go. It's a lesson on mutual exclusive outcomes. To do this, you need to know a couple of symbols. The first symbol is what we call, it's a cup. It's an upside down U because you can put things in it. Yes? It means together. So when we put things together, we use that symbol. The conjunction we can use there is or, something or something. All right? There's this, and we use this one, this chapter, this unit, I should say. An upside down U can be thought of as a cap. So we call it a cap because you could think of it as a cap on a bottle. Yes, this means overlap. And instead of or, we're going to use the word and to represent this. So I have here a little GIF that shows a kind of a Venn diagram and shows that there is overlap always between these two circles. And in our problems today, there won't be any overlap, or at least we hope for. If there is, we have a bit of a mess to sort through. All right. Here goes then our main outcomes. We are, first of all, going to understand when, the term, sorry. Yes, mutually exclusive. When two things do not have any overlap, we call them mutually exclusive. Okay, so think of them, they don't share well. They're exclusive to each other. All right. You should know when things are mutually exclusive, understand the concepts of unions and intersections, and then finally be able to compute probabilities using Venn diagrams and formulas. So here's our first set of formulas. If things are mutually exclusive, and mutually exclusive is two things which don't have any overlap, so you can see there A and B, right? You can think of A as something like maybe, I don't know, how about the odd numbers? Or you could think of B as being the even numbers. And again, odd numbers on a die, 1, 3, 5, right? Even numbers, 2, 4, 6. There's no way that in one of roll you could get both of those. So when we're mutually exclusive, it's pretty simple. We can just say, add the two probabilities. Yep, what's the probability of the first, probability of the second, add them. Yeah? So this would be a mutually exclusive event. Make sense? All right. So we're going to take the union of these two, and we'll just add them up. Here's an example. What is the probability of rolling a die and getting an odd number or a 6? So we take the probability of the first, odd number, 3 out of 6. Probability of 6, 1 out of 6. Again, there is no overlap because the odds are 1, 3, 5. Probability of 6, right, does not share anything there. So we just add those two things up. We get 4/6, which is 2/3. All right. And, okay. By the way, don't reduce your ratios here because 1/2 plus 1/6, we don't have a common denominator. So leave them in the same form, 3/6 and 1/6. Yeah? Leave them in the same denominators. Unlike yesterday where we were multiplying these things together. All right, finally, that took a while. Here's example 2. First of all, there's a diagram of two things, just like the one we did, where they're mutually exclusive. Notice there's no intersection. Here, probability of A and B, there is intersection. That's going to be messier. We're going to have to figure out what that intersection is, right? And if I add up the probability of A and B, I'm going to be counting that area twice. And so we need to figure out how to get rid of it. Yes? And this is the formula then for getting rid of the overlap. So if two things are not mutually exclusive events, so there is overlap, right? Then you're going to add the probability of A plus the probability of B, and then you got to subtract A cap B, which means A and B. Whatever that overlap is, you got to cut it out, because you've cut it twice. You've counted it twice. Okay? And here's an example of that overlap. So what is the odds of getting an odd number or a prime number? So we have the prime numbers there, 2, 3, and 5. And then we have the odd numbers. All right? And you notice the odd numbers, there's 3, 1, 3, 5. Primes, there's 3, 2, 3, 5. Yeah? And so we take the probability of the first, 3 out of 6. Take the probability of the second, 3 out of 6. You add those up, you're going to get 6 out of 6. Hopefully your brain says, what? That doesn't make sense. This cannot be a probability of 100% because we still have the possibility of getting a 4 or a 6. So, clearly, this tells us then we have to consider the overlap. Yes? We have to somehow subtract out that overlap. So here goes, take 2, same problem. We take the probability of the first, 3 out of 6, the probability of the second, also 3 out of 6. But now I subtract the overlap. There's 2 items, remember, 3 and 5, that were in both sets. So I subtract them out. Now I do the math. 3 plus 3 is 6. Minus 2 is 4. 4 out of 6. There's my probability. The probability is 2 out of 3. Now you ask, well, what's the 1 out of 3? What's the leftover? Well, remember there's 2 items that were on the outside, right? 4 and 6. So that would represent the 2 out of the 6, which is 1/3. All right? So that takes care of everybody. Example 4. A little bit more complex. We're going to deal with rain and temperature. So let's say we have a 60% chance of rain today. Yeah? And we have a 70% chance of being over 90 degrees. So clearly this is like a summertime. We have a 45% chance that it will be both rainy and over 90 degrees. They're going to ask us, what is the chance that it will be neither rain or above 90? Wow, lots of complex words there. So let's start with a Venn diagram. We show that there is overlap, and we're going to be looking for the region that is actually outside of everything. So let's start with the inside, the 45. Now the question comes, okay, if I have 45 that's being shared by both between the 90 degrees and the rain, how do I find the stuff that is just rain? Okay? And how much do I know for the right degrees? Then we'll be able to find how much is left over for the neither region. So let's take the 60% chance of just rain, and if 45% chance is the overlap, now that means there's 45% chance of rain, that means I clearly have some left over, so that means there's 15% chance, 25. Why did I write a 15 there? That's not right. No, yeah, 15 is right. That's good math, 15. 15% chance of just 60% of rain. Now again, I'm looking for the percentage of what is the probability of it being over 90 degrees. I'm having a little bit hard time finding it. Maybe if we look, no, that's not it. There, 70% chance that it will be over 90 degrees. So if I take the 45 degrees and take out from the 70, that's going to leave me, 70 minus 45 is 25. So I have a 25% chance of it being just over 90 degrees. No rain. All right. Now, how much is left over for the neither region? Well, all these should add up to 100%. So let's take 15 plus 45 plus 25. And I add those up. Here I go. Look at that good math I'm doing. 5 and 5 and 5, 15, carry the 1, 85. So that's not 100%. So I need another 15% to get to 100. That means there's a 15% chance of there being no rain or over 90 degrees. All right. Now, let's look at just some phrases and be able to tell, is this mutually exclusive or is this not? Okay, we got one more example, example 6, once we go through these phrases. So let's say you go to the pet store, you buy a pet that flies. Or, option B, you buy a pet that has no legs. Is there overlap? Pet that flies, no legs. Clearly there's no overlap here. Yeah? These items are mutually exclusive. So we write that out, mutually exclusive. And you can feel free to abbreviate that. Now, let's say you order a pizza on a Friday, and that pizza has pepperoni. Pizza has mushrooms. Okay? Is there overlap? Well, some people would say, no, you don't mix those things. But most of us say, yeah, you can mix pepperonis and mushrooms and have them on the same pizza. There is overlap. Clearly, there are people that commit this great sin. So these are not mutually exclusive. Okay. Then we come to selecting a football player. Outcome A, 4-year varsity starter. Outcome B, player is 14 years old. Well, is there overlap? 4-year varsity starter, player is 14-year-old. Highly unlikely that a player started playing when they were 10 years old on varsity football. So, most of us would say there is no overlap. These are mutually exclusive events. Okay? You can't be both a starter and less than, and being 14-year-old. Okay? And finally, if we're going to go look at radio stations, again, we've talked about this before. We have KDWB. So the first letter, we're going to say, starts with a W. That's event A. We have 3 letters after that. Next one, we have call letters that contain 3 E's. Now, again, the first letter has to be W or K. Could the last letter be 3 E's? Why, yes. Could the first letter be W? Yes. So is there overlap? Yes. You could have both outcomes happen at the same time. Okay? So these are not mutually exclusive. Clearly they made a mistake there in their solutions and they said is mutually exclusive, but they explained it right. All right. Let's say you're in high school. Let's say you're a guitar player and you want to put together a band. Yeah? And let's say you have 30 people who play guitar. I guess that's a lot, but let's say you do. Some play bass, some play lead, some play rhythm guitar. So you categorize them. And the first thing we realize is that there are 4 extremely talented musicians, yes, that play both lead and rhythm and guitar. So you put that 4 in the dead center because they are part of all 3 groups. Then we say, okay, we got 14 that can play lead or rhythm, but no bass. So they go in that spot above, yeah? 14 in lead and rhythm, but not bass. Okay. Second of all, they have 2 that can play bass or rhythm. So find the bass rhythm overlap and put a 2 there. All right, good. Next, we have 3 that can play the bass only. They only have 1 set of skills. They play the bass guitar. And then finally, because there's 2 regions that are still unknown, we need to know one of them, right? So we're after how many on the lead. So we have to know how many are lead and bass. And if we look carefully, there's another phrase that says, there are no musicians that do lead and bass. Yes? And so that region there, that is marked with a question mark, is actually 0. So let's erase the question mark and put a 0. All right. Now 30 should equal 14 plus 4 plus 4 plus 2 plus 3 plus 0. And 14 plus 4 is 18, plus 4 is 22, plus 2 is 24, plus 3 is 27. Well, clearly 30 is not 27. We're missing 3 players, so therefore the lead-only players are 3. All right? And there we go. Your problem set is going to come from 2, 3, and you're going to be doing 2 through 6 and 12 through 16. Good luck with your work.